In this module, we're going to take a look at some of the things that go into planning storage on Azure. So what are some of the things you need to think about before you even begin implementing a storage solution? So there's a few things that you want to be taken into consideration. Number one, what types of storage services are you going to use? And this is ultimately going to come down to what your goal is when you work with Azure. For example, if you're working with virtual machines, you're going to need most likely premium managed storage. That's the best type of storage for virtual machines, but that comes with trade-offs such as cost. How are you going to design your storage? Are you going to have multiple storage accounts in multiple regions, one storage account that's replicated? And then how are you going to give access to managing those storage accounts? Billing. Obviously, cost is a factor. The types of storage you choose, the amount of replication you choose, the amount of data you choose to store is going to impact how much you ultimately spend on storage. Now, personally speaking, at the end of the day, storage is one of the cheaper services that's available. When I look at applications and solutions that I've deployed on Azure, the storage billing accounts for a fraction of a percent of the overall cost. So it's not necessarily as big a consideration as you might think. Then finally, account management. This comes down to how you access the storage. Are you going to have one person manage the storage account, but other folks have access to the contents of the storage? It's important to keep in mind that with Azure Storage, there are two fundamental sets of permissions that you deal with. There's the subscription administrators that can create and delete storage accounts. And then there's other users that don't have access to Azure, but have access to the contents of your storage accounts through either access tokens or by nature of having access to your storage keys. So how you grant those users access, recycle keys, provide keys, etc., are all things that you've got to think about as you go in and as you begin to set up your Azure storage solution. So to begin, let's take a look at some of the different major Azure services, and then the types of storage that you would ultimately choose for these. So we'll begin with infrastructure. Infrastructure is when you want to deploy the operating systems and most basic components. You want to deploy and manage those yourselves. So for example, I want to store files on Azure, so I put a file server on a Windows Server 2016 virtual machine, and I deploy that on Azure. That's an example of infrastructure. Now, when we deal with infrastructure, again, typically virtual machines, there's two storage services that we'll typically interact with. Disks. Disks are VHD files. So if you're familiar with VMware, the VMDX files, or Hyper-V, the VHD or VHDX files, this is the Azure equivalent to a virtual hard drive for a virtual machine. Now, you're going to store those within Azure. In the recent last couple of years, Azure's gone to great lengths to optimize storage for virtual hard disk files. And so they've introduced what's known as a persistent disk. They've introduced two levels of storage, premium and standard, and they've also introduced the notion of what are called managed disks. So the decisions you make come down to what level of performance you want, how much storage you need, and then how much work you want to put into managing those. And at the end of the day, the simpler you make it for yourself, the more you rely on Azure to do for you, typically the more that's going to cost. So for example, the newest feature is what's called a managed disk. A managed disk is when you don't worry about it at all, essentially. You create a virtual machine, you say, I want it to have VHDs, but I want them to be managed VHDs. Azure takes care of creating the storage accounts, the containers, the replication. It ensures that you're in the right fault domain. It ensures that availability groups are set correctly. You don't have to worry about anything. On the flip side of that, if you want to use unmanaged disks, you get some additional flexibility, but you now have to create the storage accounts. You have to manage the storage accounts. You have to distribute the storage accounts accordingly. So there's additional knowledge and work on your part. Now, there's a course within this series which is dedicated to virtual machines, and in that particular course, we're going to talk about at length how we choose between managed and unmanaged, and then how specifically that works for virtual machines. And then you'll also see it in some of the demos. The next component is files. Now, files are file shares that reside in Azure. These work in two ways. Number one, I can create an Azure file share. Now when I do that, it exposes the SMB protocol. I can now map a drive to that file share. So I can sit on my Windows machine and I can map a drive to my file share that resides within Azure. Additionally, if I have a Linux virtual machine, I can create a mount point that points to a storage point in Azure. So I can sit there and just work in my standard operating system, copy and paste files, and those files are stored just as if it's a local file share, except it's in Azure. Now the second way this works is I can actually have that file share sync with a Windows file server. So consider a branch office. You don't want to give every user access to the file share. You give them access to a shared file server, and you configure that file server to sync with an Azure file solution. It gives you a simple way to have, a very large file repository, but then only the files the users need, they're copied on demand from Azure to the file server and are now available locally. For applications you build, you've got three native solutions. You've got blobs. This is a very scalable, extremely high performant, kind of catch-all for storage. You can write any kind of data to a blob. You can retrieve any kind of data from a blob. You don't have to worry about managing any of the underlying storage infrastructure. You also have a table. Now, these are not your traditional, SQL Server, Oracle, Microsoft Access, spreadsheet, columns and rows style tables. These are what are known as NoSQL tables. They are key value lookups. So you don't have named columns necessarily, and not all tables have the same number of columns. Everything is based on a name, such as, first name, and then a value such as Corey. And essentially, you can scale to petabytes and petabytes of this unstructured key value based data. You don't have to worry about any scaling operations. It's dynamically scaled based on load. It's dynamically replicated to be kept available, and it's dynamically secured. This is excellent storage for simple applications that just need a place to write data. For example, log files. In fact, most Azure services that have log files, if you want to enable things like logging or debugging, you turn that on when you deploy the service. The first thing it does is say, okay, I need a storage account. And what it does in that storage account is it creates a table. And then it simply writes whatever debug data, whatever diagnostics data, whatever logs or analytics into that simple table structure. The next one is a queue. A queue is, kind of works like this. I have an application. That application, let's say it wants to store a piece of data. Well, rather than it having access to the database and then in real time storing that data in a database, it can drop that data in a queue. Now the data will just sit there in the queue and wait. A second application will come, read the queue, pick it up, process it, and then do something else. So, a common example for queue usage, let's say that I want to send out emails. I go to a website and I want to say, hey, subscribe to your website, send me your newsletter. I can have my website store email addresses in a queue for all the users that sign up for my newsletter. And then once a day, I have a second web application, read through the queue, gather all the email addresses, and then send the newsletter and leave the queue empty again. So it's a way to do asynchronous communication between two different applications. One application writes to the queue and then simply forgets about it. When it writes to the queue, the application is done. A second application looks in the queue. If nothing's there, it does nothing. If there's data in the queue, it takes it and does whatever it needs to. Email, store it in a database, or take some other action. So very simple to create Azure queues. And again, a lot of internal Azure components rely on these 5 structures for the bulk of their storage operations. So just kind of reviewing a little bit what these items are. So tables are one of the abstractions. Key attribute pair stores any type of data you want, auto load balances to meet traffic, and then you can access this using the OData protocol, which many applications and data processing tools support. Tables, reliable, low latency, high throughput messaging system. Again, this notion of decoupling roles where you have a web server, maybe a processing component, the web server writes data to the queue, the processing component comes in, picks it up, and does something with it. The key here is it's asynchronous. The application that writes to the queue is done when the queue writing is finished. When it's written to the queue, The post-processing comes later. Usually these things run on a schedule, like once a day, once an hour, whatever schedule is appropriate. And then we have files, which is a way to move on-premises applications to the cloud. SMB share, standard protocol, works for both Windows and for Linux. And then it's always stored within the structure where you can map drives to it, or you can synchronize it to an on-premises file server. For disks, there's 4 major abstractions for disk. And again, these apply specifically to virtual machines. So we have what are known as premium and standard. The only difference here is standard disks are HDD-based disks, so spinning disks, which simply means they're slower. Also cheaper, but they're slower. Premium is all SSD-based, so it's much faster, but it's more expensive. And then finally, they can both be either managed or unmanaged. In an unmanaged scenario, you're going to be responsible for creating the VHD files and the underlying storage accounts. If you want redundancy, you've got to choose to replicate those storage accounts. If you want to have greater throughput, greater performance, you can create multiple storage accounts and distribute the VHDs accordingly. So with unmanaged, everything is up to you. With managed, you simply say, I want a VHD, and Azure takes care of the storage accounts. It takes care of placing the file so that it's fault tolerant and ensuring it's replicated so it's highly available. You as the administrator, you don't have to do anything other than indicate, I want this to be a managed disk. Now, when we go through some of the demos throughout this module, you'll see me create managed and unmanaged disks, and you'll get a chance to see what the difference looks like in the UI. For billing, Azure Storage is billed in a couple of different ways. So, number one, the amount of data that you transmit determines your bandwidth cost for storage. Now, data, it's free to put data in. You pay when you remove the data. So you can store data within Azure. You only pay for the bandwidth for data for going out. You don't pay for the bandwidth for data that goes in. Additionally, transfer between Azure services in the same region are also free. So I can go, for example, from East US to East US 2. Doesn't cost me anything. From East US to something in Europe, I do pay for the data transfer there. The second thing you'll pay for is transactions. So every time you do something in storage, you get charged for it. Now, I don't know the rate off the top of my head, but it's thousandths of a percent of a penny. So you might have millions of transactions within Azure, but at the end of the day, they only add up to a couple of pennies. So while it may seem like something that's kind of scary, it's like, oh well, every time I touch something in storage, I pay for it. You do, but it's incredibly low. And in the grand scheme of things, if you, for example, run a virtual machine on Azure, and you run that virtual machine for a month, 99% of what you're going to pay for is the VM compute. A very tiny portion of that is going to end up being storage. So at the end of the day, if you're planning Azure, unless you're talking about storing, billions of terabytes of data, the storage costs are going to be the least of what you worry about. And then finally, storage use, and this is just how many gigs you use. And again, in the grand scheme of things, this is pretty negligible. It's not a significant portion of overall Azure cost. So while it is something to be thought about, it's not a major consideration. And then finally, every single request that you put in is either classified billable or non-billable. I know it may seem like an obvious thing to say, but you can look at your reports and you can look at your subscription bills, and you can see the number of billable versus non-billable requests. And then finally, a few other little quick notes. Standard versus premium storage. Premium uses a slightly different billing model. You use for what you provision rather than what you use. So to give you a simple example, with standard storage, if I provision a 1 gig file, but I only put out 10 megs of data, I'm paying for 10 megs of storage. With premium, if I provision a 1 gig file, I pay for 1 gigs of storage. So something to keep in mind when you think about how I deploy and how I manage VMs. It may seem like an obvious choice. If you deploy a virtual machine that's going to do a job like, say, a domain controller, you just put that on premium storage because it's why wouldn't you? Well, it's a lot cheaper to put that on standard, which is hard drive-based storage. And in many cases, for example, if you put a domain controller on Azure, they're not disk-intensive workloads. The fact that it's running on a slower disk is not going to make a difference at the end of the day. So understanding the workload and what that workload is going to be asked to do is pretty key when it comes to deciding the types of storage that you're going to have. And then finally, if you enable analytics, realize you're going to pay for that too. So, it might seem, okay, well, I'm just going to turn on analytics on everything. You'll pay for the storage for all those different storage accounts that contain analytics data. So again, a consideration as you're beginning to set things up. Turn it on when you need it, turn it off when you don't.